Welcome back. In the previous video, we kickstarted the new topic with our discussion on aldehydes, and this is pretty much the introductory video for ketones. Now, as with when we did our functional groups and naming, we learned how to identify a ketone, and this is what I probably had then, and I probably will have it now. I don't think it changes because I go to a new topic. All right. So neither of this, I call one as R, the other as R prime. Neither R nor R prime cannot be equal to hydrogen, because then if one of them becomes an hydrogen or both of them, then it contributes to an aldehyde, right? So where we can really start is, this is where we can start. CH3, CH3, CH2, okay, etc., etc., etc. Right? You can also have benzene on both sides, or you can have a metal and a benzene. The options are, unlimited. Okay, we're going to look at more as we go further. This is just to tell you what a ketone is. Now, unlike an aldehyde, a ketone, the C double bond O, which is called the carbonyl, right? This itself is often referred to as carbonyl. Okay, as a whole thing, it is called a ketone. But if someone asks you what is C double bond O itself is, it's called a carbonyl group, right? Now let's go ahead and name a few ketones. Let's start with this one. Okay, this is the foundational ketone. It should have been here, but I guess I didn't think of it before I made it. All right. As with any naming, you got to first identify the longest chain. And you should start numbering from the side containing the functional group and is much more closer to whichever carbon is much more closer to the end. That's where you start. So you start from here. So 1, 2, 3, 4, 5, and 6. So 6 carbon. I purposefully made all this to be 6 carbon, so I don't need to repeat myself. So 6 carbon is hexane, right? Now, if you remember, if this is the only functional group present, then we don't use the word oxo, okay? We use what is ketone is on, okay? So basically, this is in the second spot, right? 1, 2, 3, 4, 5, and 6. So this is in the second spot, and this is a hexane, and all you got to do is hexane, get rid of the E, and replace it with an O and E. So hexanone, but it's in the second spot. So the carbonyl group is in the second spot. That's why I specifically mentioned this. So it's 2-hexanone. As always, you get rid of the E, and then you put the O-N-E, so that's hexanone. But we have to specify exactly where. This is a major difference between aldehyde and ketones. Is aldehyde, the C double bond O is always on the very last carbon, but with the ketone, it only exists inside the ring or inside the chain, not on the outside of the chain. Okay, so this is how you name a foundational ketone that doesn't contain anything but the ketone as the only functional group present. Now let's move over here. Or actually here, okay? Now here, there's a problem. We have still 6 carbon, but which side should I start numbering? Well, like I said, you should start from the side containing the functional group, but also the least number of carbons, which makes this the only candidate. So 1, 2, 3, 4, 5, and 6. So again, hexanone, right? But we don't just say on, because there is not just one. There's 2 ketone groups here. So hexadione, right? Well, hexane dione, actually. We got to get rid of the E, but instead of just writing O-N-E, which is for 1 CO, we have 2, so dione, di for 2, okay? Okay. But then we also have to specify the positions like earlier. So it's 2,4-hexadione or hexane dione. okay? Because we have the carbonyl group in the second and the fourth positions. Now let's go over here because this is even easier. It's kind of the same as, okay? So as long as it's not a double bond, things are fairly straightforward. Now again, this doesn't contain a double bond, but again, you start numbering from the side close to the double bond O, which is the least number of carbons attached to the C double bond O, which makes again 6 carbons. So this is 1, 2, so it's hexanone, right? Or we have a chloro here, right? So 4-chloro, that's the first name, okay? And then this is 2-hexanone, right? 4-chloro, this is exactly the same. You don't make any difference to it, so 2-hexanone. Okay, we just got rid of the E. So basically when it's anything else like chloro or methyl, you don't really have a whole lot of change to the name, whereas this is a little tricky, okay? So the name itself changes. So again, we still have 1, 2, 3, 4, 5, 6. This is a higher priority group compared to this, so you start numbering from this side, right? So it's hexane and hexanone, right? That's how it should appear, but we have a double bond, right? So as I said earlier, hex is the parent, so X, it's 4-ene, right? That's where the double bond is, and then 2 is where the carbonyl is, and on. So basically, we have to accommodate this 4-ene into the 2-on. So it's 2-hexanone when it's nothing but the carbonyl or anything else. But when it is written this way, then when a double bond comes in, you have to accommodate the double bond. The only way you would be able to do it is do it this way, which is X4-ene 2-on, because 2 is where the carbonyl is. That's where the 2-on is. The double bond is between 4 and 5, so it's X4, and double bond is ene, and that's how we end up with this. So with practice, we have done it for the previous exam. So it's just, we did it for alcohol, this time it's for a ketone or aldehyde, right? Now, there are several methods in sharp contrast to the aldehyde I want to go through, but I don't want to dwell too much on the mechanism because the actual application part of the aldehyde and ketone, I got enough mechanism, so I don't want to overload you with mechanism on both the synthesis and application part. So we're going to keep the synthesis pretty much straightforward. Okay. As with the aldehyde, this is an oxidizing agent. Okay. Or the process is known as oxidation. Whenever you see chromium, it should tell you it's an oxidation. All right. Like primary alcohol gave you an oxidation with the same number of carbon. That's the key thing. Whether it's aldehyde or ketone, whatever you're using it to oxidize with, you should retain the same number of carbons. So here we have 1, 2, 3, 4, and 5. This is chromium trioxide, and this is DCM, which is dichloromethane. Okay. We've used this in a lot of our laboratory experiments this time around, which is DCM. So we have 5 carbons, so the product should also have 5 carbons. Now, where do we put, so primary alcohol, when oxidized, give you aldehyde. Secondary alcohol, when oxidized, will give you ketone. Okay, this is a secondary alcohol. You see this carbon containing the OH contains only 1 hydrogen, so it's a secondary alcohol. So secondary alcohol, when oxidized, gives you ketone. All you got to do is get rid of the OH and put a double bond O. You should still maintain the same number of carbons. So this is one of the first synthesis method. And I want, as I did earlier, this is very important, so I'm going to write this as a take-home message. Secondary alcohol, okay, when oxidized, this is very easy. Primary alcohol, when oxidized, gives you an aldehyde with the same number of carbons. Secondary alcohol, when oxidized, gives you a ketone with the same number of carbons. You see, we still have 1, 2, 3, 4, and 5. So this is the product of this reaction. Contains the same number of carbons. That's very important. I got a couple more synthesis methods which are also equally interesting and not that difficult to remember. So I'm going to come back with more of those. All right, so stay tuned.